So hello brother, so this particular question is what they asked us to do in this skill assessment 5.7. Here we are asked for the system represented in the state space as follows. Like as it is now, they say convert the system to one where the new state vector z is this. So that is what we want to do. So the first thing we're going to do is this. So this is the equation given. This is the equation. So as it is now, what we want to do now, the first thing is that in this equation, this particular one, this particular one is a, that is x is equals to a plus bu. So we need to get something out of this. So now, and we have already been told what z is in the question. The question will also specify the value of z as it is in this equation. We are given z to be matrix 0 1 minus 2 minus 4 x. So we are also going to put z there. So let's write z out. So z is equal to, we have 3 1 minus 2 minus 4 x. So this is z. So these are the things that will be given in the question. So what we want to compute now is that this particular formula, z is equals to p inverse of x. So it tells us that this value associated with z, this matrix, is the p inverse, and that p inverse is what we're going to use to compute the entire thing. So first is that we need to get the formula out, the formula we are going to use to solve this particular problem. It's all based on just knowing what the formula states, and the formula is that is the new variable we want to convert it into. It's going to be in this form: p inverse of a p of z, then plus, then it's going to be p inverse of b of u. It's going to be u, and the output equation is going to be y, and it's equal to cp of z. So this is what we want to actually do. So what we want to look for, p inverse a, then times p, also p inverse times b. So those are the things we want to get out of this. It's very simple. So now the first thing is, let us get our, we already know this one, this particular matrix of z is already p inverse. So we need to invert it to get our p out. So to invert it, we just need, you can use the calculator. It's very easy. Just punch these values in a calculator. Punch it inside your matrix. You go to matrix mode. Then you punch these values inside your calculator. You now go and click on x raised to power minus 1. That is that inverse on the top beside 1 on the calculator. So like on this calculator now, this, after you have gone to shift matrix, you go into this matrix mode. First of all, go to mode, enter matrix. You now go to shift matrix mode. In that place, that is where you now click on data. You store this matrix inside the data. Now after you have stored, let's say you stored it inside matrix A. So in matrix A, that you now find the A inverse. You find the inverse of that. So when you find the inverse of that, you are going to get this in directly without having to sweat at all getting the inverse. So you just need your calculator to do that. So your P, which is now the inverse of this P inverse, P will now be equal to 0.4. With your calculator, you get all these things out. 0.2, 0.1, minus 0.3. So once you have done that, you've gotten your P. Now you don't want to get your P inverse of AP. We are following this particular formula, so we need to get this out. This P inverse of AP, this particular one, we need to get it. So the first thing we'll do is we'll put everything together. So P inverse of AP, I hope this is not too wide. It's appearing too wide. Okay, so P inverse of AP, so that will be P inverse AP. So what's our P inverse? So our P inverse is that the value that associated with Z earlier is 3 1 minus 2 minus 4. Then A is from the first matrix given in the question, this particular one, this first one here. So is what is given. So we are going to put that one here too. So all these things you are also going to do the multiplication with your calculator. You don't need to sweat at all. So it's very simple. Then the third one is the P, which is this one that we obtained just now, right? So it's going to be 0.4 minus 0.2, then 0.1, then minus 0.3. So after we have obtained this, it's going to be, so we'll now multiply these together. So if we multiply these together, we're going to get, so we can use our calculator also to put this three. We store one in matrix A, store the second one in matrix B, store the third one in matrix C, and multiply them together. So if you don't know how to do that, probably if we meet, I'm going to show you how to do that. 6.5 and 9.5, and this is minus 8.5, and this is minus 11.5. So after obtaining this that we obtained now, so we have obtained one of the things we needed. Then the next thing is we want to get this value. This is P inverse multiplying B. So we also need to do that here. So P inverse multiplying B. So what is P inverse? So that will be 3 1 minus 2 minus 4. Then the B is from the question, from the first matrix there. So once we multiply them together, we are going to get minus 3 minus 11. We're going to get this one out. Also the third thing we need to get is the CP. Look at this very well. We also need, for the output, you also need to get CP. So what is CP? So CP is going to be, what is our C? We know our C from the question, 1 and 4. Then the P, of course, is the one we got earlier. So 0.4 minus 0.2, then 0.1 minus 0.3. So we'll now multiply these together. This is this is 1 by 2, and this is 2 by 2. So the result is going to be 1 by 2. So it's going to be 1 by 2. So it's going to be 0.8 and minus 1.4. So having obtained these values, these three values that we have obtained now, we'll now put them back into the original formula, this particular formula that we wrote earlier. That is exactly what we need it for. You understand? We just need to put everything in this form, in this matrix. Z dot is going to be this Z, then this U, and this is, so that's it. That is what this question is asking us to do. Very simple. So now we just put everything together. So Z dot is now equal to, so we have gotten that one is 6.5 6.5 minus 8.5. Then this is 9.5 minus 11.5. So, and this is going to be Z1, Z2. Then plus, then our B is going to be minus 3 minus 11 U. Then our output equation Y will now be equal to 0.8 minus 1.4. This one will also be Z1, Z2. So that's our final answer for this one. So concerning this particular question, so for the system represented in state space as follows: convert the system to the one where the new state vector, is this. So, and that is what we have done. So we have gotten this now from there. So now the next thing we want to do is to look at the second question. Now for the original system in that skill assessment, there's a find the diagonal system that is similar. So what they want us to get is the diagonal system that is similar. So what they want us to get is the diagonal system that is similar. And in the actual fact, what they're asking us to get is this value of this matrix A. Yeah. So now let us see how we got that. Okay, now let's go back to our whiteboard. So in this place now, they want us to get that. So let us now let's look at what they want us to do here. Now looking at our question, let's write down the matrix again. The matrix that we are working on is this 1 minus 4, then 3, and minus 6 as the matrix we are working on from the question. And this is 1, 3, U, while Y is equal to 1, 4, H. So that's the matrix we are working on. So the first thing we need to do here to be able to get the diagonal is to get the eigenvalue. So to get the eigenvalue, we need to set the determinant to the determinant of lambda I minus A to 0. So determinants of lambda I, which is the identity matrix, minus A, we set it to 0. That's the first thing. And to do this now is very simple. So we're already used to doing stuff like this. So it's just going to be lambda 0, 0, lambda minus A. So A is already given in the question. 1, 4, 3 minus 6. So minus 6. So if we subtract this from this, we're going to get this out. We're going to get lambda minus 1, and this is 4, and this is going to be minus 3, and this is going to be lambda plus 6. So this one as it is now, we will now find the determinant. Determinant is multiply the major diagonal, subtract it from the minor diagonal, subtract the minor diagonal from it. So that will be determinant of lambda I minus A is equal to lambda minus 1, then lambda plus 6 plus 12 equals to 0. So from here now, we'll just multiply this, expand this brackets. That will be lambda square plus 5 lambda, right? Plus 5 lambda plus 6, right? Plus 6, okay, minus 6 is gonna be minus 6 plus 12, and this is going to be lambda squared plus 5 lambda plus 6. So if we find these ones, this is quadratic equation. So lambda from here, you can punch this in your calculator, and that will give you minus 2 and minus 3. So after you've gotten this, so you will now guess the eigenvector. These are eigenvalues. You need to get eigenvector using this formula. The formula is AXI equals to lambda xi. So we are going to use this formula to get the eigenvector. So A is that matrix from the question. So we just need to put them here together. So and that's going to be, put the matrix 1 minus 4, 3 and minus 6. Then x, this is x1, x2, and will be equals to lambda. So we have to do this for each of the lambda. We have 2 lambda, so we have to do for each of the lambda. So minus 2 first. Take minus 2 first. So x1, x2. So at this point, we're now going to open this brackets. We open this brackets. So once we open this brackets, we are going to have this to be x1 plus 3x2 equals to minus 2x1. Then also this is going to be minus 4x1 minus 6x2, and this is going to be minus 2x2. So here now we will multiply. So to be able to eliminate equation, to make this have the same coefficients, to make the x1 have the same coefficient, we multiply this first equation. Let's call this one equation 1 and call this one equation 2. So the first thing is we are going to make equation 1. So we can say multiply equation 1 by 4, because the coefficient of x1 here is minus 4. Just use 4 to multiply this, so that when you add them together, it will be eliminated from the system. I believe that is understood. So we just say equation 1, equation 1 times 4. So when you multiply equation 1 times 4, that will be 4x1, then 4 times 3, that will be 12x2, then 4 times 2, that will be minus 8x1. So let's call this one equation 3. So we call it equation 3. So now that equation 3 is now having the same coefficient as equation 2, we can add equation 3 and 2 together. So we can add equation 3 and 2 together. So okay, brother. So we just need to add these two together, these two equations. If we add this together, that will be gone. So we're left with this one here, and that will be, so that will be 6x2. 6x2. That will be 6x2. And if you look at the right hand side, you will see that you have x2 and x1 there. So you just put them down the way they are. So you have minus 2x2 minus 8x1, right? So you bring the x2, you bring it to the left hand side. So this is going to be 6x2 plus 8x1, right? And plus 2x2 rather, plus 2x2, and you'll be left with minus 8x1 there. Okay, so this is going to be 8x2, and you'll be left with minus 8x1 here. So if you look at this very well, you'll see that you just need to bring them just bring x2, just make x2 the subject of the formula here. That will be minus x1, right? So that will be minus x1. So we've been able to see that the relationship between x1 and x1 is minus 1, right? So we can write the vector like this in every form, that is x2. Can write it like this, x2, sorry, like this, x1 all over x2 in this form. So it could be whatever, it could be any value. So if this if x1 is c, then they'll be using the relationship between them. The other one is going to be minus c. This will be minus c. So but the minimum value, or one of the values it can have, is 1 and minus 1. So we can just use this one as our vector. So the minimum values can have is that 1 and minus 1. So we just use that as our vector. So because that's the relationship between them. So once you have gotten this for the first lambda, we will also do the same for the second lambda. So now doing the same for the second lambda, we will also get some results as well for that one. Now let's go for the second lambda. For lambda equals to 3. So when lambda is equals to minus 3, so what's the situation? What's going to be its own situation? So it's going to be using the same formula, a xi will be equal to lambda xi. So using the same formula, what is a? A is that matrix, the matrix that is given from the question, minus 4, minus 6. Then our x is x1 and x2. So this is going to be lambda, that will be minus 3, lambda, that's x1, x2. So using the same procedure that we did earlier, we'll just do the same thing here. So we expand the brackets. So we expand the brackets. Once we expand the brackets, we're going to get x1 plus 3x2 minus 3x1. And for the second one, it's going to be minus 4x1 minus 6x2 minus 3x2. So the same thing we did for the other one, we also do it for this one. So what we'll do is we'll multiply, just call this one equation 3. Just call this one equation 3, equation 4. Then you can now assign some things to them. You can say equation 3 times 4. So equation 3 times 4. So that we'll see that we are multiplying equation 3 by 4. So that will be 4x1 plus 12 as 4 times 3, that's 12x2, and that's gonna be minus 12. So that will be minus 12x1, right? So after obtaining that, we're now going to add them together. So we had these two equations together. So we have 6x2 will be equal to minus 3x2, yeah, minus 12x1. Alright, so after we have obtained that, so we'll bring x2 together. We bring x2 together, so that's going to be 6x2 plus 3x2 will become minus 12x1. So we add them together, so that will be 9x2 will become minus 12x1. Right, so at this point we will now make x2 the subject of the formula, so by taking the coefficients to the other side, so divide both side by 9, so our x2 is going to be equal to minus 12 all over 9 x1, and this is going to be 3 here 3, 3 here 4, so our x2 is minus 4 over 3 x1, right? Minus 4 over 3 x1. So we know the relationship between x2 and x1, which means if x1 should be equal to 1, then x2 will automatically become 4 all over 3 minus 4 over 3. You understand that? So that's at least, that's the minimum it can be. So whatever, just know this relationship between them exists. So we have x1 and x2. We write it in vector form. So meaning if our x1 should be equal to 1, if you put that 1 here, that means x will become minus 4 over 3, right? So this is the vector. This is how the vector will look like. That's how the vector will look like. So at this point in time, we have been able to find the two vectors associated with the lambda, the eigenvalues. So the eigenvectors will now be combined together to form a matrix. So once we form a matrix with it, that matrix is now what is called the P inverse. It's called the P rather. That's the matrix. So the matrix is called the P that we need to solve our problem. So now let's go. So our P this time around is now equal to, now the first vector is 1 ratio minus 1. Then the second vector is 1 ratio minus 4 over 3. So this is the P that we need to solve our problem. Now, now that we have obtained P, we also need to obtain P inverse. So P inverse, with our calculator, we don't need to stress ourselves. We can get P inverse straight away from the calculator. Just punch this value inside the calculator and click on that x raised to power 1 close to that button to give you the inverse. You just invert it and that gives you the inverse. So you don't need to stress yourself about that at all. So your P inverse is just going to be 4 minus 3, 3, and minus 3. So that will be the P inverse. So we have obtained P and P inverse. So we can now apply our formula, the usual formula that we know for the Z transformation. That formula is what is guiding everything here. That Z dot is equal to P inverse A P Z now plus P inverse B U. So that's our state equation, and our output is going to be Y. So that Y is going to be CP. It's going to be CP Z. That's it. So this is what we want to achieve here, was this one. So at this point in time, we just need to compute this P inverse AP, and we also compute P inverse B, and we compute CP. So once we compute the three, we're good to go. So let's go ahead and do that. So that's going to be P inverse P inverse AP. So we know the three matrices. We just need to punch them in our calculator, put them in our calculator, and we just get our answers straight. No wasting time for this one. 1 minus 4, 3 minus 6. Just put them here. Then put all of everything in the calculator. Multiply them together. You know how to do that? You go to matrix. From matrix, you go to shift matrix. So when you get there, you will just go to data. So that data, that's where you're going to be storing the three. So you store one in matrix A, you store the second one in matrix B, you store the third one in matrix C. So the three matrices, you store them 2 by 2, store them in the three matrices. So once you store them there, you just multiply them together. You come back to the matrix, you say matrix A times matrix B times matrix C. So it's very easy. So once you do that, you're going to get your answer straight away without having to sweat multiplying, because the scary thing about this is if you try to do it with your hand, you might run into some error. You might make a mistake along the line, so which is very very painful, after all the efforts. So it is better you use your calculator to do it. So this is going to be 4 minus 3. Then this is 3 minus 3. And this one is 1, 3. And this is going to be, this is 2 by 2 and this is 2 by 1. So the eventual answer is going to be 3 by 1. Sorry, 2 by 1 and 2 by 1. 2 by 2 multiplying 2 by 1 is going to be 2. It's going to be 2 by 1. Okay, so having done this is what we're going to get. Okay, so now we also need to get CP. So to get CP, so our CP is, we know what our C is, and we know what our P is. So let's put them together. So this is going to be 1 minus 1 is 1, and this is minus 4 all over 3. So when you multiply them together, this is 1 by 2 and this is 2 by 2. When 1 by 2 multiplies 2 by 2, the eventual answer is going to be 1 by 2. You know what that means? So it's going to be 1 by 2. That is minus 3. Then minus 13 all over 3. So now that you have the 3 together, so the only thing you need to do is to put everything together in that formula. In that formula, you just need to put everything together. So we just need to go back to this formula, the formula here. So we need to go back to that formula and put everything together. Okay, so at this point we need to put everything together. So our Z is now equal to Z dots is now equal to minus 2, 0, 0, minus 3. z plus, then this one is going to be 13 minus 12. Yeah, and this is going to be u, while our y is going to be minus 3, then minus 13 all over 3. So x is z rather. So this is the final answer. Let me zoom out so that you can see everything at a go. So this is the entire solution. So this is now the solution to the problem. You can see that in the question, the answer, what they got this one, we got this value inside the z, but we did not get this value and we did not get this value. So the only thing I can say regarding these two values, the only thing I can say regarding these two values that we did not get is that the value of the eigenvector can be different things. Probably they use 8 minus 8 for their own eigenvector, or they use some other things, some other numbers, and that number is you can't have one answer for that, so you can have different answers. So I think that is what gives us these values. That's why these values are different here. Probably they use other eigenvector values, and we use the minimum. We use 1 and minus 1. We use 1 and minus 4 over 3. So that's where I think the discrepancy is. But regarding the diagonal matrix, it is always the same. You see that the diagonal matrix we got is also the same as theirs. We look at it very well, you see that we have the same diagonal matrix. So if, as long as the diagonal matrix is equal, I don't think there is any problem getting with the answer. As far as I'm concerned, I think this is also one of the solutions to the problem. Okay, so that is it. Okay, thank you, brother. Take care.